Hi, this is Team Talker, and these are our three members. And this is the demo video for the Lab 4 Part 2. First, let's log into our My Database. We should use the Racket database because that's where we store the data and show the tables. You see, currently we have these two tables in our database. And then we're going to show how our code runs. This is the directory for Lab 4, and for Lab 4 Part 2, we mainly have the main Python file and the cluster Python file. We should just run the main Python file because in the main Python file, it calls functions from cluster.py. So let's just run it. And the third parameters in the interval in minutes basically the posts under the technical field of the Reddit update in an hour's manner, maybe like update per 6 hours or 12 hours. But for the demo video, it's kind of impossible to show the update like how it did in real life because it will take really a long time. So we just use 1 minute here as an interval in the demo video, but in reality, you can use, for example, 6 hours, which is 3,600 minutes here as input. So let's just use 1 minute as interval here. And it is running. And also, we don't set 5,000 posts in default because it will take a really long time to scrape for the demo. So we just, for example, say scrape 100 posts for the clustering for every interval, and the interval is 1 minute. Is 1 minute to update. And next, because we will dynamically update the database, we have to connect to the database. Here I have to input the configuration of the database, like the example here and the password and database name. The database name is Reddit, as I just showed. Now the driver open the Firefox browser and will scrape approximately 100 posts automatically, and it scroll down pages automatically, and it will take a while. Now the scraping is finished. Let's first take a look at the output here. Show when it is scraping part down and the data processing, and also output the processed scrape data to the terminal, which is approximately 100 posts, like with input here. And it also draw the clustering graph. The result is here. We can see that there are 9 clusters, and each cluster is presented in different color. And that is basically the results of the clustering of the posts. And now it said it has write to the database, but we have to enter the table name we want for the data. Let's just make it like Docker demo part 2. Yes, to in reality use, we can just set this database name in default in our main Python file, but for the demonstration of our demo video, we just add this input. Okay, Docker demo part 2. Yeah, and instead the data is stored successfully to the database. And now, because the interval is 1 minute, and now the program will sleep for 1 minute. And if you don't want to continue the scraping, you can just input quit here to exit, but here we want to continue, so it doesn't input quit here. And now it's waiting for about 60 seconds, which is 1 minute. And after the 1 minute, the program will open the Firefox browser again and do the same thing. So let's just wait for the 1 minute now. I'm still waiting for the 1 minute here. And now 1 minute has passed, and now the driver open the Firefox browser again. But we can see it actually doesn't update because the interval is pretty short. In the demo video, as I stated before, in reality, you can input the third parameters as 12 hours or 6 hours. And also it has drawn the clustering graph again. And all the thing is the same again. Also the name one for the database, also Docker. What is the name before? Demo part 2. Now it's stored to the database successfully, and now we don't want to continue, so we just type in quit. And now it says it's exiting the program, and now the program is down. So that is basically what we did for the part 2. And we can also take a look at the database and show tables again. See, there is this table we just created in our Python main Python file, and we can see what's in the table. And these are the data. They are all stored in the same data table in the Reddit database. So it shows that the real-time database interaction also works well. And finally, we can take a look at the code. Seeing our visual code, this is the Python cluster file, and these are the main Python file we just run, and we import cluster to the main file and call the functions. In the main Python file, they are mainly the scraping part, the processing part, deep interaction part, and this is the automation, a database configuration part, and this is the automation set while true. And in this part, we call cluster.document vector and cluster and identify keywords, which is the two function in our cluster Python file. And this is the draw cluster function, which is the visualization of the clustering results. And so next, my teammate is going to show how we write the cluster part in the notebook. It's basically the same as the one in our cluster Python file code, but they're going to show them in the notebook, which is more intuitive.
To take the document into a vector, first we'll use the output data frame from the process function. Here is what it looks like. Here are some of the functions we'll use. We'll use the tk tokenize. We'll use some of the functions from Gensim, and we'll also use the string package. So here is the function that I wrote that takes in a data frame and then outputs a data frame that includes the document vector. So here, for this line, I remove all the punctuations for each title, and then I turn every character into lowercase. Here, I declared a model that is distributed memory. The reason we're not using distributed backward words is because distributed backward words is more about the distribution instead of the definition of words. So here we're using distributed memory. For tag data, we're basically tagging each document in each document is basically each title. We're basically separating the words and tagging each one of them for like each document and giving each an ID. And then after that, we build the vocab with the data that we just tagged. And then we also train the model with the data we just tagged. After the model has been trained, we will use infer vector to get a vector for each of the doc from the lowercase titles. So after creating all that, here are all of the vectors we wanted for each corresponding title. We output a data frame. So first is the title, is the original title, and the corresponding keywords that we have for that title. This is for clustering purposes for later. And then we'll have vector, which is the corresponding vectors for that document. And here is what it looks like as a data frame.
My portion of the code for this lab 4 part 2. So I'm just going to say that this code basically performs the clustering on the Reddit dataset. So it's based on these vectors here, vectors gathered from the keywords and the title as mentioned by Wendy. And the way I wanted to go about this was using a t-SNE plot, and it's just designed to process the data, the text data, identify the natural groupings within the data, and highlight the keywords associated with each group. So I'm going to break down each of those components. First, I had to import scikit-learn, so I needed the feature extraction text, the TF-IDF vectorizer. So that converts a collection of the raw documents into a matrix of those TF-IDF features. What TF-IDF means is term frequency inverse document frequency, which is used to transform the text into like a representation of these numbers that could be fit into these machine learning models. Then I needed to import k-means, which k-means clustering is a way of trying to separate samples into like an n amount of groups of equal variance. Then I needed to import t-SNE, which is T distributed stochastic neighbor embedding, and it's just a way to visualize like high dimensional data and break it down to 2 dimensions. So from here I am going to explain the rest. So let's see here. The first thing that I need to mention is the function clusters Reddit post titles based on their content and identifies keywords for each cluster. So there's just the data frame that I'm importing with vector.df. Then I'm also using the TF-IDF vectorizer function to transform the list of keywords into the TF-IDF matrix. Then I implement the k-means clustering on the group of Reddit titles into clusters. For each cluster, The function identifies the top keywords using the TF-IDF scores, and it does it by summarizing the TF-IDF scores of all documents within a cluster and picking the top terms. What I end up getting is the same data frame with added columns for the cluster label each title is assigned to, and the keywords associated with each cluster. So what we end up with is the full script here to visualize the clusters. And so that is it. Thank you for listening.